Dark matter is a hypothetical phenomenon. It is a type of matter that cannot be seen with telescopes. Is that a paradox? Matter that cannot be seen? Dark matter is deemed to exist in such abundance that it accounts for most of the matter in the universe. Does the paradox deepen? The existence of dark matter is inferred from its effects on the visible universe, while its presence cannot be detected directly. Its effect reveals its existence. This makes dark matter one of the greatest mysteries in modern astrophysics. Some say that up to 90% of all the matter of the universe exists in the dark matter form, or as a subset of it that is termed dark energy. This doesn't solve the paradox, does it? Actually, the existence of dark matter was theorized as a means for solving a paradox, for solving the great paradox in astrophysics. The existence of dark matter was first postulated in the early 1930s to account for the stark discrepancies between observed orbital velocities of stars in the Milky Way and the laws of orbital mechanics discovered by Johannes Kepler in the early 1600s. In our solar system, the orbital velocity of planets diminishes with the square of the distance. The velocity of the planets at the lower left reflects the gravity-forced dynamics of orbital motion that Johannes Kepler had discovered. With the force of gravity diminishing with the square of the distance, the outer planets move more slowly, because if they didn't, the centrifugal force of their motion would drive them out of the solar system. Ironically, the opposite relationship between speed and distance has been measured in the motion of stars. It has been reasoned from this observation that the mass distribution in a galaxy must be vastly different than it is in a solar system, because stellar orbits are simply not possible under the laws that Kepler had dealt with. In order for this thing to work, it has been postulated that the entire galaxy must be surrounded and be pervaded by a large invisible mass that somehow solves the problem. That's like saying, we really don't know how this thing works. The problem is that this approach, such as adding fudge factors in imaginary entities which can't actually be detected, doesn't really work, does it? It all adds up to grand fairy tales that one is supposed to take on faith. But where do we find the truth by which everything makes sense and which can be recognized to be truthful? To answer this question, we need to take a step back and look at what the paradoxical problem is based on. When one looks at a paradoxical problem from a higher level standpoint, where gravity is not the only force in the universe, suddenly an answer becomes fairly obvious. The answer is that our box is too small in which the paradoxical reasoning is conducted. The entire problem of paradoxical stellar movements is based on the assumption that only the weakest force that exists in the universe, the force of gravity, may be considered, which in addition has an effect that diminishes with the square of the distance from its source. While we see these factors being dominant in the intimate domain of the orbits of the planets around the Sun, where the planets are close enough to be affected by gravity, Different principles evidently come into play at the larger distances, where gravity no longer has a hold on celestial objects, where higher-order principles affect the movements of the stars. When we deal with distances in the order of tens of thousands of light-years, the effect of any central gravity is zero, no matter how massive the central gravity might be. But why would we limit ourselves to considering only the force of gravity, which is after all the weakest force in the universe, which in addition to being the weakest force also diminishes with the square of the distance? Why would we keep our box of perception limited to only that? Why would we keep it that small? It is a well-known fact in physics that a vastly stronger force than gravity exists, which, in addition, has an infinite range. This vastly greater force is the electromagnetic force, the electric force of attraction between two charged particles is by far the strongest long-reaching force in the universe. It is 39 orders of magnitude stronger than the force of gravity, nor does it diminish with the square of the distance as gravity does. The problem is that the electric force is deemed not to exist in cosmic space by some high-ranking command of the keeper of the box. The electric force is not allowed to be considered. The command is that it does not exist. Of course it does exist. It exists in the form of plasma in space. Plasma is rare on Earth, but it is native in space. Plasma is a soup made up of two basic particles that all atoms in the universe are made of. They are named protons and electrons. Both carry a complementary electric charge. The proton has a positive charge and the electron a negative charge. Both particles also have a specific size and mass. The proton is 1800 times more massive. By their mass, the plasma particles have a gravitational attraction to each other and to all forms of mass. But by their electric interaction, as I said before, the acting force is 39 orders of gravity stronger. However, and here it gets interesting, both of these plasma particles are extremely small. They are too small to ever be visible. The largest of the two, the proton, is 100,000 times smaller than the smallest atom in the universe, and the electron is 1,000 times smaller than that. These particles are simply invisible. Their invisibility qualifies them for the term dark matter. Nobody can see plasma, nor does plasma ever emit light. Plasma is dark, transparent, and invisible, even while it is the primary state of all mass in the universe. Researchers at the Los Alamos National Laboratory have come to the conclusion that 99.999% of the mass of the universe exists in plasma form, and less than 0.001% exists in atomic form. In other words, the universe exists primarily as vast volumes of dark matter that carries an immense electric charge. The dark matter becomes visible only when the movements of plasma particles affects the electron movement in the shells of atomic elements. The resulting agitation causes the atoms to emit light. Only atomic structures are able to emit light. When we see light in space, we see atoms agitated by dark matter in motion. The dark matter itself remains dark at all times. Every sun in the universe is lit up by this process of dark matter in motion, interacting with atomic elements. In the case of the sun, the plasma particles, which are the fabled particles of dark matter, become fused into atomic elements. Where this fusion takes place, the interaction is extremely intense, and so is the resulting light. The emitted light is energy derived from moving plasma. This is also where the critical function of dark matter is located. Dark matter is not a dead thing that hangs in space like a fog. It is electric energy in motion, and the motion itself is caused by the fusion process on the surface of the sun. When the electrically charged plasma particles, also termed dark matter, become fused together into atomic elements that are electrically neutral, a portion of the electric force becomes neutralized. It ceases to exist. The plasma fusion process thereby becomes a sink in which dark matter is consumed and turned into atomic elements that flow away with the solar wind. The consumption keeps the plasma streams flowing. The flowing plasma streams are electricity in motion. When electricity flows in two parallel wires in the same direction, the two wires are drawn together by the magnetic field that the movement of electricity creates. When the electricity moves in space, as plasma, the entire dark matter soup becomes pinched together ever tighter, which of course increases the magnetic field and further increases the pinching effect. Eventually a point is reached when the plasma gets all tangled up and a type of explosion occurs. A number of research efforts have been made to explore what happens when the pinch effect goes critical. The blue geometry shown here was produced in a high-power experiment at the Los Alamos National Laboratory. It was discovered there that at the tightest pinch, the plasma gets magnetically curled backwards into a magnetically contained bulb, where the pressure builds up. Another researcher explored this region statically to explore how the process works. He termed the magnetic fields the primer fields. In the dynamic experiment, the excess energy in the system that caused the explosion at the node points gets dissipated in a hollow ring-type structure. In space, these structures are rarely visible, as dark matter simply isn't visible. Only in extreme cases can we actually see some parts of them. One such case where parts of the primer fields become visible is our own galaxy. NASA has photographed these two gigantic structures shown here of concentrated dark matter, which are visible by their interacting with faint atomic elements, whereby they are emitting X-ray light and gamma-ray light. The large primer fields, however, are evidently too faint to be detectable with available instrumentation. However, what we see here, and also what we cannot see directly of the dynamic movements of dark matter, solves the original paradox of the movements of the stars in our galaxy. The stars are not orbiting in a gravitational bound system, but are instead moved by the electromagnetic dynamics of the primal fields system, motivated by the plasma streams of dark matter. This means that the entire galaxy is rotating as a complete unit, while it is constantly expanding from within. Evidence also exists that the same process that powers our galaxies may collectively power entire clusters of galaxies. The blue ring image that you see here, that is centered on a cluster of large galaxies, is obviously not the result of gravitational lensing, since gravitational lensing doesn't affect light in this manner. Instead, the blue image that you see reflects in the large the typical geometry that has been discovered in the laboratory in high-energy experiments. It has been discovered in the lab that by extreme concentration, plasma combines into a ring of 56 filaments that eventually combine into 28 filaments and then 14 and so on. One such ring of filaments has been discovered centered on supernova 1987A. The ring structure shown here is typical for high-energy plasma streams. This type of pattern is apparent in the blue ring that is centered on a large galaxy cluster. The galaxy cluster doesn't create the ring by bending its light. The ring is formed by the immense plasma streams that are feeding the cluster. We appear to be looking down the barrel of a very massive plasma stream that is feeding its black matter into the galaxy cluster system below, which powers the cluster. The blue light of the ring is emitted by atoms reflected in the path of the plasma stream. The circular light show also appears faintly when no atomic elements are encountered in the path. In this image, we look once again down the axial center of a giant plasma stream system, streaming towards a major galaxy cluster. The faint arcs appear to be light reflected by the different inner rings of the structure of the plasma stream. Another way by which we can see the existence of dark matter in plasma streams in space is by their effect on the alignment of planets and galaxies. While plasma fusion on a sun motivates the plasma flow, the sun consumes only a part of the plasma. The rest flows on to the next star in line. The electric attraction that is propagated through the plasma streams ties the connected stars into linear clusters like beads on a string. While we look at three-dimensional space flattened out into a two-dimensional image, the linear alignment pattern that often results is visible in the star fields as a clearly visible feature wherever we find dense star formations. The same linear pattern that we see in fields of stars is also visible in fields of galaxies. In this partial field of 35,000 galaxies, termed the Capodimonte Deep Field, many strings of galaxies are visible, including some rather long strings. And it is here where the existence and characteristics of dark matter in space is critically important for us on Earth. Our galaxy, the Milky Way galaxy, is just one link in one of these types of chains of galaxies. Our galaxy has an inflowing plasma stream and also an outflowing plasma stream. Depending on the length of these streams, each of them has a different electric resonance characteristic. In our case, one of the streams has a 140 million year resonance, approximately, and the other a 62 million year resonance. Both of them together reflect themselves across the entire galaxy, affecting the plasma density throughout time, which in turn affects the climate on Earth in a big way. From their combination, the Great Ice Age epochs resulted. When the plasma density is high, the Sun is more active and the Earth gets warmer. These up and down patterns reflect the combination of the two 140 and 62 million year resonance cycles, reflected in historic temperature change gleaned from deep-sea sediments by analyzing the changing oxygen-18 isotope ratios. In these records, we see two deep ice age epochs occurring. The first of these lasted about 10 to 20 million years, at around 450 million years ago. One of the large mass extinctions of life has occurred in this epoch. Those deep glaciation epochs are rare. The second one, of the same magnitude, is occurring in the present. It started about 2 to 3 million years ago. We know from ice core samples from Antarctica that for the last 500,000 years, the deep glaciation, which may have been caused by the Sun going inactive, were interrupted periodically for a brief span of warm climates, termed the interglacials of continuous solar activity. We are presently in one of the interglacial warm periods. It has run its course. The plasma density in the solar system is already fading. In a galaxy of 400 billion stars, vast networks of plasma streams become entangled so that the timing of the individual events at a local level are best forecast from historic precedents and from present plasma dynamics, such as the fast-fading solar wind. Since the Earth's climate is created by the Sun, which is powered by dark matter in the form of plasma streams, reasonable forecasts can be made by analyzing the changes in plasma dynamics. One can forecast on this basis that the Sun will likely go inactive in roughly 30 years. While we cannot see the dark matter plasma streams that affect our climate, we can take note of the effects it has. And if we are wise, we will prepare our world with the type of infrastructures that can enable 7 billion people to live and prosper in the darker and colder world of the coming ice age. One of the questions that has not been addressed in the field of dark matter science, or plasma physics as it may also be called, is: where do the plasma particles come from that form the dark matter plasma universe and the atomic elements created by plasma fusion? Indeed, where does dark matter come from? One person has hinted at a possible answer. The name is David Bohm. David Bohm is the man whom Albert Einstein had once referred to as his successor. Bohm sees the so-called empty cosmic space as not being empty at all, but sees it as a sea of apparently disorganized infinite energy that has an underlying implicate order with an expressed explicit order unfolding from it. The explicit order may be seen like ripples of water in terms of latent energy in space. Since plasma particles are known in nuclear physics to be themselves but constructs of points of energy, called quarks, which are entities that cannot be further divided, it seems reasonable that one begins to recognize the quarks as but expressions of Bohm's explicit order. In this case, plasma simply exists as an inexhaustible element of space itself. It may be said in this context that space and plasma and energy are one, and that from this one the universe unfolds from the very small to the very large. While we cannot see the plasma itself, we can see its dynamic effects. This is also how we can see the start of the next ice age years before it happens. We see the dynamic effects leading towards it. We see the solar winds rapidly diminishing. We see the heliosphere shrinking. We see galactic cosmic ray flux increasing, together with a lot of secondary effects such as increasing clouds, increasing drought conditions, and Arctic warming, and so on. By recognizing the unfolding dynamic trends, it becomes possible to forecast the general time frame when the Sun goes inactive, by which the next ice age begins. It becomes further possible thereby for us to build the infrastructures that we must have in place for us all to be able to continue to live under an inactive Sun. Only humanity, of all the forms of life that we know, has the capability to look so deep into the invisible and to orient its policies in the present accordingly. Of course, as we do this, we thereby discover ever more of our humanity. As we do this, a lot of long-cherished false theories will likely fall by the wayside, such as orbiting stars, internally heated suns, global warming, and so on, and of course also the more devastating false theories, such as the theorized need for war, the inevitability of nuclear war and economic collapse and resource depletion, and also the false theory that demands depopulation, and so on. False theories inspire fear. Fear is the mind killer, said Frank Herbert in Dune. Science and truth opens the prison doors of all the false theories that have chained us, if we strive for the truth to be free. This means that we stand at the threshold today as we explore the nature of dark matter with the mind, which no one can see except with the mind, and prepare our world for the Ice Age events that have never occurred in the entire history of civilization, but which we can see occurring 30 years into the future, and this with a certainty as if they would happen today. That's the dimension of the power of our humanity. It enables us to step up to higher ground in human living and avoid an otherwise ugly and certain doom. That's how we come of age as a people.